Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to my YouTube channel. Today's video would be a very interesting video because I have received so many comments from different people about how to visualize ORCA output files effectively and easily, of course. So I've already made a video about ORCA visualization and told you about different tools like JMOL, Avogadro, and Chemcraft, where you can visualize ORCA output files. But because those software are free and they do have quite a lot of functions, but still, GaussView is one of the best visualization softwares that we computational chemists have, and that's really easy to use. It has so many functions. And one would love if they can open the ORCA output files directly into GaussView. Yes, you got it right. So I'm telling you today about how to open the Gaussian output files in GaussView, just like, the ORCA output files in GaussView, just like Gaussian files. And let's see, this is a Gaussian file. You can open it in GaussView. But if you have an ORCA output file, you won't be able to open it in GaussView because um, its format is different, and you can see that this is an optimization file in ORCA, and we can't really open it in GaussView. So let's see how we can open this file in GaussView. So I have found this really cool tool called OfakeG, which is developed by Dr. Tian Lu, who is the author of multi-WFN. And if you go to this website, it's here, and I'll write it down in the description as well. And then download this tool called OfakeG. So here we have already downloaded it, and I'll just copy it here for our ease. So now we have got the tool, which is right here, and this folder contains two files. One for the Windows, which has .exe extension, and the other one is for ORCA. So we'll explore both of them today. If you want to open the Windows one, just double click it, and it will give you a warning that it's from an unknown publisher, just going to run anyway. So you'll get something like this. And if it asks you to input the path of ORCA output file, so let's give it the path of these files. It also has examples folder where it has many different ORCA files, but I'll give it one of my own ORCA files just to see if it works correctly with this latest version as well. So for example, I have this file. So what I'll do is I'll copy this address from the address bar and paste it, and then backslash, and then I will copy the name of the file and paste it here. So in DOS, you can just right click and it pastes thing instead of pressing Control V. So if we press enter now, it processed the optimization file and it has generated a file called ch3iopt-orca fake.out. It means that it's a fake Gaussian file. It's not a real Gaussian file, but it will do the job. Press enter to exit. You press enter and it exits. So now if we drag this file onto GaussView, you see that you can see the molecule and you can also see the steps. And if you go to results optimization, you can see all the same things that you would see in a Gaussian file. So this is really cool. Like you can convert the Gaussian ORCA optimization and frequency files simply to Gaussian, and then you can use them as they are. So let's try one more with Windows, and then we'll go to Linux. So now I will copy this, and I have another file with ORCA. It has a log extension, but I'll show you that it's an ORCA file. So let's paste this one and press enter. So it had so many optimization steps, but they were written to the fake file. And now you can open it and you see you can have a look at the optimization curve and everything. And here we go. So now we're gonna try this one in Linux. So I'll use the Windows subsystem for Linux that you can get from Microsoft. And this is really cool to have Windows subsystem for Linux in your Windows machine where you can use a full-fledged Linux as well. So that will show you, even if you are using it on a high-performance computer, anything which has Linux, you can use this file over there like this. So one thing is, if I ls here, this is this folder, and I cd OfakeG, and then I'll see that this is the file for Linux. And if I want to convert, I'll delete this file and copy this one into this folder so that you can see the file here and the program here. So if we run it, we just run it with /OfakeG and then give it the name of the file. So it's that simple on Linux. If I press enter, does the same thing, and you get a log file. So what if you want to run it from in any folder without being into this folder? That is also possible. Yes, it is. So for that, if I just tell you, you have to copy this file to your /bin folder. So you can just say scp OfakeG /bin. If you press enter, it says you cannot copy to bin because you don't have admin privileges. So if you just do sudo scp OfakeG /bin and press enter, it will ask you for the administrator password. You put it there and you're all done. But in case you are on an HPC and you don't have the admin rights, what will you do then? In that case, you can put it in a folder of your choice and define it in the bash RC profile. How can you use it? So let's do that. So for that, if we just go to the home directory, and we can create a folder here, like let's say we have a folder software, we can make a folder bin, which will be our local bin. So if I enter bin and I copy the same file from this address over here, to here. To see these bash commands, you can watch my videos on bash basics. And if I do that, I can see that it is copied here. So now if I want to see the present working directory address, it is this one. And I'll copy this, and then we'll edit our bash profile and put this address over there. So now we'll just press cd to come to the home directory, and I say nano.bashrc, which opens up the bash rc profile. And if you just scroll down, go to the end, I want to define the path for my home bin folder, so I can just say this export path is equal to this whole path, and then I can save this with Control O, X, and then I exit it with Control X. Now I will source my bash profile to load the new things which we just defined. And then if I call it now, you see it works without being in its folder. So let's try it now from this folder and where it is not present. So maybe we can simply delete this one. Uh, that's always with Windows, so don't worry about it. We'll use it right here where it's not present. I'll delete these fake files, and then let's see /mtd test ORCA output files where we can see these files. So if I call it OfakeG and then this one, it does the job. Now there is one more thing. If you want to uh, do run this on all the files present in this folder. So there are two out and one is log. So I'll just rename this one to out as well to keep them in the same format. We can run it in a loop. So if you want to know about the loop, you can watch my video about the Linux. So I just want to say for install.out do OfakeG $I done. So if you write this command, it will run on all the out files in the current folder and convert them into Gaussian files. So let's see that there are only three original ORCA files, and if we press enter, it runs on all of them, and now we have the out files for all the files. So this was about how to open the ORCA output files into GaussView, and you can see the optimization steps, the energy, the frequencies, and everything. I hope you would have liked this video, and I'll try to make more videos about uses of ORCA, which is the second largest software used in computational chemistry. And it's free. People can use it who don't have access to Gaussian or any other paid program. They can use ORCA for free. And if you have got access to GaussView, then you are lucky enough that you can use ORCA output files into GaussView as well. So if you have any questions, you can post in the comment section, and you can like the video or subscribe to the channel if you want to get updated about the upcoming videos. Thank you very much. Bye bye.